All right, so for this next example, we're going to say that g of x is equal to f of 1 over b times x, particularly 1/2 times x. And this will transform the function in an interesting way. So this one, I'm going to do a different example to try and think about how we can come up with this. So if I wanted to do, um, let me just do it down here on the bottom where there's, well, I could do it here where there's a little more space. So I'm gonna say g of, and I'm doing this specifically, g of 2 is equal to f of 1/2 times 2. Right? Does that make sense? Okay. What is 1/2 of 2? 1. So g of 2 is equal to f evaluated at 1. So what I'm going to do is I'm going to look at my f function when x, this is my x value, when x is plugged into f of x, it is equal to 2. So f of 1 is equal to 2. But that is my g of 2. I don't have a 2 here for g, so I'm going to make kind of a separate table. In other words, g of 2 is equal to 2. So if I go over 2, I'm going to graph 2. Okay? So g of 2 is equal to 2. Now I'm going to also very precisely choose g of negative 2. Well, that's going to be equal to f of 1/2 times negative 2, which is equal to, what's 1/2 of negative 2? Negative 1. Well, what is f evaluated at negative 1? Well, I got to scroll up a little bit. When I have x plugged into f of x, I get negative 2. So that's equal to negative 2. In other words, g of negative 2 is equal to negative 2. In other words, for my function g of x, I have the point negative 2 comma negative 2, if you think in terms of x comma y. So I plot the point um, negative 2 comma negative 2. So this point is on the grid. Okay. So if I look at the point on the grid, that's what I get. If I crank through and I do the rest of the math, I'm going to get it. What does it look like it does to the graph? Well, if I crank through, basically it's either going to it's going to horizontally compress or stretch, depending on that value of b. Okay, because we're if I were to continue this, okay, if I were to continue this, I'm going to run into those things. In other words, what is um, it? So without finishing this, let's say make a conjecture. So your textbook is saying, look, g of x is equal to f of 1 over b times x. And then what happens if b is 0 to 1? Okay. That's what they want you to think about. And then they say, what happens um, if b is greater than 1? Okay. And so if we continue down that path, it just stretches. So we're going to say that it can stretch, uh, or compress horizontally. Now, this is the example in your textbook. I'm going to pull something up on a calculator and kind of give you an idea of what we're doing here. So let me give you a little more practical example, okay? And you guys could do this on your calculators as well. Clear everything out. Hit second y equals and choose option number 5. Oops, not option. I wanted option number 5. No, option number 4. Turn off all the plots. Oops, got an error. Y, second y equals. Option number 4, turn off all the plots. Then go to y equals, clear everything out. And I'm going to do a basic x squared, x squared. And then down here, I'm going to, in parentheses, put 1 divided by 2 times x, and then square that. Okay. So what you'll see is that it horizontally compresses or stretches it, right? So if it is a fraction, if b is greater than 1, it stretches it. If it was a fraction, it compresses it, just like before when it's written in that form. Does that make sense to you guys? Okay. That's basically example number 4. Okay. The bell's going to ring any second. Does